Hello everyone, I'm Frank, and welcome to Frank Puzzles, and this is today's hard level difficulty puzzle. And it's called Copycat Scratch Fever by Calvin Ball and Chinstrap. And here are the rules. Excuse me. Normal Sudoku rules apply, which means in every cell in the grid, place a single digit from 1 through 9 such that there are no repeats in any row, column, or designated 9-cell region. We have slow thermos, where values on the slow thermo must not decrease starting from the bulb. So that is every slow thermal here. So we could have something like, say, 3, 9, 12, and 26. This would be valid because these digits along this thermometer must not decrease. What you could not have, though, is something like 399, 26, because it's not, actually, that could work. What you could not have, though, is 398, 26, because it's decreasing from this cell to this. 99 does work, because 399, it is not decreasing from the 9 to the 9 here. So that's an example of how slow thermos work. We have X sums, where outside cells on a slow thermo have a value equal to the sum of the first X values seen in the clues row or column, where X is the value of the first value seen, of the first cell seen, it should say, probably. Or it's the first value seen, or the value of the first cell seen, I would say. For purposes of solution check, outside cells are not used. Okay. So X sum. So outside cells on the slow thermo have a value equal to the sum of the first X values seen in the clue. And the reason why it's values, we'll get to in the next rule set. But say, so this couldn't work as a 3. Oh, values. So these are values. But maybe we had like a 6 here as a value. Then this would work for this X sum clue because X would be 6 here. That's the first value seen in this row. And then the first 6 values must add up to 26. Which could work if we had, I don't know, 6, 5, 8. What is that? That is 19. And 1, 2, 4. So this could work here. For example, so this 6 would be X, because that's the first value seen in that row. And then you need to add the first 6 values. So if these values were 5, 8, 1, 2, and 4, then that would be, again, 5, 6, and 8 is 19, plus 1 is 10, 20, plus 2 and 4 is 26. And that would equal to 26. That's a value outside of this puzzle. So that's an example of how values work. Or, sorry, X sums work. And why is it values? It's because we have copycat cells, where we need to place 9 copycat cells into the grid so that there is exactly 1 copycat cell in each row, column, and 3x3 box. And each copycat cell must contain a different digit, and the value of a copycat cell is the digit in the cell rotationally opposite itself in the grid. 180 degrees rotation around the center of the grid. For example, if row 2, column 3 is a copycat cell containing the digit 5, and row 8, column 7 contains the digit 9, then the value of row 2, column 3 is the digit in row 8, column 7, which is the digit 180 degrees rotationally opposite it, which is a 9. So if this were the copycat cell and this were 9, then the value of this cell is a 9, because that's the digit that's 180 degrees rotationally opposite of it. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. Let's start by figuring out what these can be. We can have, obviously, 1 here. We could technically have all of these be 1. That's very unlikely. So this could be 1. This cannot... Well, it could be 1 again, because we could have copycat cells. Then you could have 1 again, and then 2. But we know this is 9. Could be 9 again. Has to be 8, because we only have 1 copycat cell per box. Could be 8. So these are 1 through 8 in value. Guaranteed. This is 1 through 9. And this is 2 through 9. 1 through 8. 1 through 8. This could be 1 through 9. So this is interesting. How are you going to have 5 digits here? That are going to sum up to 8. The values here can only be 1 through 4 times. Or sorry, 5 times. Right? You can only have 1 copycat cell here. But even then, to add up to 8 at most is going to be very difficult. Especially for 4 values, right? You would need to have the 4 essentially have a copycat cell in somewhere in that portion, which copies that digit that's in the 4 cells, right? Because if you don't have a copy of the values, if you have 1, 2, 3, 4 by itself, and in fact it has to be 1 that's doubled. So you have to be 1, 2, 4 as the values, and plus another 1 to add up to 8. So that means this is going to have to be then 8 value 8, 8, and 9. Somewhere like this. Because one of these is going to have a 4 as the value here. Because we can only have the values 1 through 3 4 times. Because only 1 copycat cell. And then you have a 4 available. And then to add up to 8 for 4 values, it's going to have to be 4, 1, 2 as the minimum digits, and then the copycat cell be 1. So this is going to be, at the end, have to be an 8 in value, which means we have to have 8 here, and this is going to have to be an 8, 8, 9 triplet here. So one of these is going to be 8 in value. We're going to have 8 and 9 as possibilities. So this has to be an 8 in value. And we could have another 8 here or another 9 here. So we know this cannot be 8 here. These are the digits 1 through 4. And then where's 9 going to be? 9 is guaranteed to be one of these digits here, because one of these is going to be 8, one of them is going to be 9, and one is going to be a copycat cell. So copycat cells cannot be here. One of these is going to be a copy, or one of these three is going to be a copycat cell. And we cannot have 9 here. So this must be 1 through 4 with 9. And that leaves the remaining digits at 5, 6, and 7. This must be increasing in value, or not decreasing in value, but since they're in the same box, it has to be, and there's no copycat there, it must be increasing in value. So this is 5 or 6, 5 and 7, 6 or 7 as possibilities. So we need a copycat cell in one of these 5. So this cannot be copycat cell either. That's an 8. We could have all of these be 8 in value. That is potentially the case. So the copycat digit here must be a 9. And it has to be in a different box than the... Well, not necessarily a different box than the 4. The 4 has to be with 1, 2, and 2 with the copycat cell. Okay. Obviously, the value of 1... there's going to have to be a value of 1 in one of these. 1 obviously is not going to be next to 8. Because the value of 1 digit is only going to be 1. So I think the value of 1 has to be here. Because we need one of these values to be 1. You could have at most 2 values of 1 here. You could have a copycat, which is a value of 1, and a 1 itself. So this cannot be 2, 3, or 4 as a value, because that's not going to be a value of 1. And we need a value of 1 somewhere on this thermometer, and you can't decrease from an 8 to a 1, or something higher than a 1 to a 1. So this has to be a 1 in value, guaranteed. And this is either with a 1 here or a 9. None of these can be... These two cannot be 1. So we're guaranteed 1 in... row 1 has to be one of these 2 digits, and we could have a 1 in value there, or 9. So we know there's a 9 in one of these 2 digits. This can't be 8. This has to be value 9. So this is value 8, this is 9. One of these is a 9, though. One of these 2 is an 8. We don't know which. And we have a copycat here. Let's make red the copycat cells, and green as the digit being copycatted. Two cells, 3 cells, 4 cells. But the thing is, 4 could be... You could have all 8s here. That could be valid. Remaining digits in this box are 1 through 4. Because 8 has to be on the thermometer, 9 has to be on the thermometer, and then we have 1 digit from 1 through 4 as a copycat cell in this box. 9 cannot be here. Oh, it could be. If it's a if it's copycat of a 2 or 3. So we either have a value of 9 here, or, sorry, digit 9 here or digit 8 here. We don't know which, though. So one of these three is being copied. One of these 5 here is being copied. We don't know which ones are. Oh. This... It's possible. You could have 2 copycat cells pointing at each other, this being a 9 and this being a 1. And that could actually work. Okay. Hmm. So 2 in value, we cannot have 1 be all these values here. 2 and 3. 3 is necessarily going to have to be 6 at least. So this has to be 6 at least. 2, well, here it can't be 2 and 1. So it'd have to be at least 5 here. But it could be more, right? And we could just have 8s all the way through. We don't know. We could have 1, 1 here. This would be 5 with 2 and 3. 6 with 3, 1, and... Oh, that's interesting. Huh. Um... If we had 3 and 4 here, the problem is these 2 values. So if we tried to have 3 and 4 here, both adding up to 8, the problem is 3 digits would have to add, 3 cells would have to add up to 8, and then 4 cells would have to add up to 8. So this would be 7 at most in value, and this would be 8 in value. But that only adds up to 15. Whereas with a copycat cell, you can only have 1 copycat cell per box. That would have to be the values 1, 2, 3, 4, and 5 plus 1, which is 16. So you cannot have 3 and 4 be here as the copycat cells. Can you have... You could have 2 and 4 potentially. Because then you have 3 digits adding up to 7 at most. And 2 digits adding up to 8. I think this almost certainly has... Well... Hmm. Hmm. Right, so how does that work? So I obviously can't be 1 in value if this is a copycat cell. So this can never actually be 6. Because we're guaranteed this is going to have the value... Oh, well... Ugh. Hmm. Obviously, the copycat value cannot be 4. Here, the copycat values cannot ever be 1, because that would then be a value of 1 on the slow thermo. What else can it be? So 4 somewhere is going to have a copycat cell in its column. And 4 cannot be here. If 4 were here, any copycat value would copy one of these cells here to be 180-degree opposite. But we need to copy the 1. So this cannot be 4 here, which means this has to be an 8 here. We could have 4 be the copycat here. This cannot be 3. Again, we have the same thing. Well, so this cannot have... So we have 8 and 8 there. That adds up to 16. If we don't have either copycats, if we don't have 4 here, well, we know, okay, so if this is copycat cell, obviously none of these would be copycat. And we'd have to have a 1 here. So this could not be 4 here. It would have to have, this would be 9. This would be 1. You couldn't have 4 here or 9. You can't have 4 here because 4 would have to have 1 and 2 with it. And then the copycat cell there. No 9, obviously. So it's 2, 3, 2, 3. This would then be 4. So this would have to be 4 with 1, 2, and then the copycat cell here. You'd have 1, 2 with copycat cell. Can you have a 3 here? 3, 1, and 4 would add up to 8 with no copycat cell. But that's not going to work because of 4 in the box. So what happens if we have 3 with a copycat cell? You can't copy the 3, at least in the same column. Yeah, that's just not going to work here. So this would have to be 2. That would be 3. But again, this is 3 with no copycat cell available. And we don't have 1 available either. So this would be at minimum 3, 2, and 4, which adds up to 9, which is too large. So we know for certain then this cannot be the copycat here as 1. So this has to be a 1 normally. So that's 1. Okay. And I think we have a similar thing if this is 9 as a copycat cell of a 1 in value. Okay. So this cannot be copycatted. Four Again, this cannot be 4 here, because it would be copycatting a digit which cannot be 1 when it needs to copycat a 1. We know this is at least 8. So we know this is 1, no 1 there, no 4 there, that's 8, right. Hmm. If 4 is here, the copycat would have to be here. If 4 is here, the copycat would have to be here. Three could have a copycat in the box. Three to add up to 3 without copycat, it has to be 3, 1, 4. With the copycat, it could be copycatting the 3 and then have 3, 2, 3. So if 3 were here, or it could be less than 8 also in value for the x sum. So if this is value 2, it would have to be 6 here in value. If this is 3 in value, it would have to be 1, 4, or 2, 3 in value. Oh. Can 9 be any of these? Well, yes. So we have to have the values be different for the 2 or... Okay, to add up to 8, 4 is going to have to add up to 8 with 1, 2, and a copycat 1. So if 4 is either of these, you would have to have 2 with a copycat. So that means if 4 is either of these, 2 would have to be one of... So if 4 is either of these, this is definitely 8. Because one of these is going to be 4, 1, 2, 1, adding up to 8. And 4 would have to be 2 in the copycat, which means 2 and the copycat would both have to be here. So this would be 2, 9, this would be 3, 4. The problem with this is, again, 4, 2, and the copycat would have to be here. But 3 can't be with 1, 3, or 4. So 4 cannot be here, which means 4 has to be here. That eliminates 4 in the rest of the box. So this is some combination of 1 and 2. We don't know if that's 8. We do know that this is a 4. And we have 1, 2, and copycat here, which means no other copycats in the column. This is 4 is obviously not a copycat. can we have 3 here? 3 would require either 1, 4, which would not work because of the 4 in the box, or 3 with a copycat, and it would have to be 2, 3, but they would be copying a digit that it's not in the set, which would then be 3, 1, 4, but then this would be 2 without a copycat, and it can't be 1 either because the 1 would be guaranteed here. So this cannot be 3. So this is either 2 or 9. This cannot be 4. One of these is 3. Well, 3 unique digits to add up cannot have 1 there. As a normal digit. So if we don't have a copycat, it would be 3, 2, 4 adding up to 9. So 3 has to be with as the copycat here. So this must be a 2, 3 pair because it cannot be the copycat. So this is 2, 3 as a pair. This must be the copycat here. So this is copycat here. These cannot be copycat. And you can't have 3 be the what it's copycatting. It has to be 2. Because 3 would require 1 and 4 to be here to add up to 8. So then that requires that to be 6. So 2 cannot add up to 8 here. So this can't be 8 here. In fact, it can't be 2 and 3. It has to be 2 and 4 at least. So it's at least 6 here, at least 6, 7, or 8 here. 3 must be with 4 and then copycatted 1. So it'd have to be 8. Well, this does not have to, this cannot be 8 here. Because again, this can't be 2 and 6 anymore, adding up to 8. Because of 6 in the row. So this is not copycat. None of these are copycat. And we're copycatting the 2 there. The 2 and 6 add up to 8. This cannot be copycat anymore, so it's 1, 2 as a pair. Therefore, this is copycat here, which is copycatting that. No more copycats in the row and box. And no, nothing in this box. 3 has to have 4 with a copycat. Then they must add up to 8, so this has to be 8. Then this has to be 2 and 5 because it can no longer be 2 and 4. So 2 and 5 adding up to 7. This is 3. With 4 and the copycat here. None of these are copycatable. So one of these is 4. And the other one is a copycat. We don't know which. That eliminates copycats in the rest of the column. Remaining digits in this box then are 3, 5, and 7. No 5 here because of 5 in the row. We're copycatting one of these, and it has to have a 1. Add up to 8. 9 cannot be here. 9 cannot be copycat. So then 9 has to be here because of 9 in the row. Remaining digits in this box are 4 with 6, 7, and 8. No 6 or 8 here. It's 4 or 7. 1 eliminates 1 as a possibility here. Because the 4 has to copycat one of these 2 cells. 9's copycatting the 2 with the 6. We have 2 and 5 adding up to 7 there. 1 and 1. 3, 4, and 1 adding up to 8. 4, 1, 2, and 1. So this has to be copycatting a 1. Remaining digits of column 4 are 3, 5, 6, 7, 8, 9. 9 is already copycat in a copycat cell, so 9 there are no repeats. This is a normal digit, so this must be a normal digit. And it could be 8 at most here. So we're going to have one of these three is going to be a copycat. We don't know which. Okay. This is 8 at most here, which means this can't be 8 or 9. It has to be 3 through 7. This digit then has to be greater than 3, so 4, 5, 6. No 6 because of 6 in the column. 4, 5, 7, 8 are the possibilities here. This value could be copycatting whatever's there, potentially. Yeah, 9 does have to be there. But we don't know if 8 is... Oh, this could be 8. Okay. Because we don't know if that's a copycat digit or not. Three and 4 are eliminated from column 3. So we have 1, 2, 5, 6, 7, 8, and 9 left. No 1 here because 1's guaranteed there. Where is 1 in column 5? Cannot be here because it's not a copycat cell, and 1 cannot be greater than any other digit, so 1 has to be there. That eliminates 1 from being here. So where's the 1 in one of these cells? It has to be there. So this must be the cell that's copycatted, which means that's the copycat here, which means this can't be copycat there. No copycat there. This obviously cannot be 8, cannot be 4. It has to be 7, which makes that 3. No 3 here. 3 and 7 eliminates 7 in the rest of the box. So this is 3, 7, and 4. No more 7 in the column. 4 is guaranteed to be one of those two because this can't be 4 anymore. 3 eliminates 3 here. It's 5, 7 as a pair. 8 is not the copycat, so we're not copycatting that. We're copycatting one of these, and it has to be either 8 or 9. So this cannot be copycatting a 9 because we already have a 9 there. So therefore, this must be copycatted whatever. So this is not copycatted. This is the copycat, and we don't know. This is 8 or 9. We don't know which it is. So this is the copycat, and it's 1, 2, or 3. We're not sure which. So that's copycatting that. Okay. These are normal values. This can't be 8, so we could have 9 there. This could be 7. 7 again, 7 again, 6 again at most. This is 2 at minimum. I mean, technically it could be 1 in value. It could be copycatting. 1, 2, because we can only have at most no 3 there, 2, and then 2. That's a possibility. No 8 there. We just don't know about the copycats here. So 1 through 7 in value, potentially. This could be 1 if it's copycatting that, which it could be. This is copycatting, so this can't be copycatting here. One of these three is copycatting. 2 has to be one of these two digits in column 6 because there's no other place for it in column 6. Can't be here because of 2 in the box. Can't be here because of 1, 2 pair in the box. Now that's interesting. So this can't be a 2. Right, these are specific digits. So we could have 3 there. 3, 9, because these are not copycat cells. We have a copycat cell there. So again, 1 adds up to 1, 2 and 5 add up to 7, 3, 1, and 4 add up to 8, 4, 1, 2, and 1 add up to 8, and 2 and 6 add up to 8 here. That's 8. We have another 8 here. This must be 8 or 9 in value because it's pointing at this cell and 9 there. Hmm. Do, 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 do. X sums here, X sums here. Um, oh, that's interesting. So this could definitely be copycat. I don't think this could be copycat. If this is so the remaining digits in box 8 are 3, can't be 3. So no 3 or 8. It's 4, 5, 6, 7, 9. So 3, where is 3 in box 8? It has to be one of these 3. So that eliminates 3 in the rest of the column. So where's 3 in... Remaining digits in column 5 are 3, 4, 5, 7, 8. With a guaranteed 3 in one of these 3 cells. 7 is already a copycat cell, so this in a copycat cell, so this can't be 7. If this is a copycat cell, it's copying a 1 or 2 in value. And that's going to be less than a non-copycat cell here. So this cannot be copycat cell there. This could be copycatting that, though. But if this were 9, it would not be possible to be in a copycat cell. So this cannot be 9 here. You could have just regular 7. Okay, so this digit could still be 4, 5, 6, 7, and 9. 1 eliminates 1. This can't be 1 here. 2 eliminates 2 here. This cannot be copycatting the 1. Because none of these are 1 in value. These have to be 3 through 9. If this is copycatting, it's copycatting a 1, which is going to be too small. So this cannot be copycat, and these digits, so this can't be 9 here. This digit must be smaller than that, so it can't be 8 or 9 here, and it cannot, that means this can't be 3. So this value must be less, but it could be copycatting a 3. That is possible. One has to be one of these 3. It can't be here. It's one of these 2 digits here. Oh. Okay, so 1 cannot be here. If this is 1, this value is 1, which means all of these values have to be 1 or less, which obviously is not going to work. So 1 has to be here, but it can't be a value. It has to be a copycat cell. So that's 1, which means the rest of the box is not copycat. The rest of the row is not copycat. So these are 3 digits less each greater than the other. So no 8, 9 here, no 7. This can't be 3, this can't be 4, because it must be increasing there. No 1 here, so one of these 2 must be a 1. This is because if this were 1, and that would be if this were 1 and not copycat, this would also still be 1 in value. And then this would have to have a 1 in value, but it couldn't copy a 1, it couldn't be a 1 because of 1 in the column. So this must be copycatting this, which means it's 6 or 7. That's a lot. So that's going to be a lot. If it's 7... I don't know what that is. Okay, so this is going to have to be a digit, obviously. Cannot be 9 because of 9 in the column. So this value is at most 8. This cannot be 1 in value, because if this were 1, it would have to have a 1 here, which is not possible because of 1 in the column. Can it be 2? No. 2 in value. You can't have 2 digits here, adding up to 2 in value. Can you have 3? 3, no. This is going to have to be a 2. To add up to 8, we would have to have 3, we would have to have at least a 1 here for 3 digits. And that's not possible because we have a 1 already in this row. So this is guaranteed to be 2. That eliminates 2 in the rest of the box. No 2, 1. No 2, 2. 2, 3 could work, adding up to 5. 2, 4 could work, adding up to 6. No 2, 5 because of 5 in the column. So no 7. And 2, 6 could add up to 8. So this is at least 5 here. No 9 here because of 9 in the column. This is going to be a lot, whatever it is. We have a 5, 6, 8, 9 quadruplet in box 7. That eliminates 5, 6, 8, 9 in the rest of the box. No 5, 6, 8, 9. This is 7. So this digit must be equal or less than 7. It cannot be 8. So there's no 6 here. This is a 3, 4 pair. That makes sense. 7 eliminates 7 in the rest of the row. This is going to be a lot. This is going to be a lot. Remaining digits of column 1. We have 3, 4, 5, 6, and 8. Remaining digits of column 2. We have 3, 4, 6, 7, 8, and 9. Okay. We don't know about... Oh, so 1 is already in a copycat cell, so this can't be 1. This becomes a 2, 3 pair. That eliminates 2 and 3 in the rest of the row, so no 2 or 3 there. It's 1. Oh, this is a copycat cell, which means this must be copycat. This can't be copycat cell here, which means this must be copycat cell here. Because we know this can't work as a copycat cell. That means these can't be copycat cells there. Either of these two, this can't be a copycat cell. It has a 1. So that means this has to be copycat cell there, which eliminates copycat cells in the rest of the column. So this is pointing at this digit there. That's fine. No 7 here, because 7 can't be in the copycat cells anymore. 2 and 3, this one eliminates 1 there, so it's 2. No more 2 here, it's a 1, 4 pair. This is pointing at a 1 in value, so this could be any digit there. This digit must be less than 2 digits here. It could be 7, 8, and 9. That is possible. One of these two is a copycat cell. Interesting. Where is 2 as a copycat cell? Can't be any of these. Well, this is a copycat cell, so neither of these are copycat cells. So one of these two is a copycat cell, but it can't be 2. One of these two is a copycat cell. I guess it could be 2 here. Or we have 2 there. Well, if 2 were a copycat cell here, that would force this to be 3, but then that would force 2 to be a copycat cell there. So this cannot have a 2 as a copycat cell there. And this can't be 2 as a copycat cell in row 8, so this must be 2 here. That makes that 3 there. That eliminates 3 in the rest of the column. 2 can't be here, so 2 in row 7 has to be one of those 2. 3 eliminates 3 in the rest of column 7. This has to be greater than that, so it can't be 4, cannot be 6, this can't be 5. Where is 3 in row 9 then? It has to be here. So that's 3. That eliminates 3 here. No 3 here. This is now 5 at minimum, which means this can't be 4 or 5. It's 7 or 8. This can't be 5 here. It's 6, 8, or 9. Hmm. So one of these is definitely Copycat. We don't know which. This digit, the remaining digits in row 8 are 3 through 9. No 9, 7 here because of they're in Copycat cells. That's fine. 3 is not in a Copycat cell there. Huh. How does this Copycat cell work? The thing is, you could copy the 1 in value, or you could copy something else completely. We do know 1 has to be one of these 2, and 2 has to be one of these 3. Um... Hmm. 3 as a Copycat cell has to be either here or here. I'm not sure which. Um... Remaining digits in row 7. It's 2 through 9. It's still quite wide. No 3 or 8 here because of 3 or 8 in the column. No 9 here because of 9 in the column. Hmm. Um... Yeah, we're just gonna have to go through the different possibilities for these, and these. Everything else is kind of already set. Um, um, 4 has to be, cannot be here. So 4 has to be one of these 3 digits here. That eliminates 4 there, so we know this is 3, 4 as a pair. What is, so this one of these 2 is going to be copying one of those. One of these 2 must be copying one of those 2. Two eliminates a 2 possibly here. Can we have a 2 be here? The answer is no. If we try to have a 2 here, that means one of these 3 digits can be copycatted. One has to be 1 and the other has to be 2. But the only place that 2 can be would have to be here. Because if we can't have 2, 1, and then copycat. We can't have 2. Well, 2 here means this can't be 2. So then we'd have to have 2, but then we'd have 1 here, and that would be copycat, and would be decreasing from the 2 to the 1. So 2 cannot be here, which means 2 in column 6 has to be there. That eliminates 2 there. So 2 is one of these 2 digits. Can we be copycatting this digit? Yeah, it's possible. If we're copycatting that, it's probably 1. This can't be... Okay. If this is if this is copycatting, this can't be 1. Because you're not going to have... That could be 1, but then that's not going to be copycat. So one of these digits is not... Both of these digits are not copycat if this is copycat. So if this were copycatting, this can't be 1, and that would have to be 1. If this is copycatting, it could be higher, but we don't know. So if this is copycatting, this can't be 1, because you can't have 2 digits that are the same or less than 1. Only one digit could be the same or less than 1. If this is copycatting, you could have 5 if this is 5, 6, and 7. And then this becomes 9. Does that work? So if this is copycatting, it's copycatting the 1 or the 5. It can't be 6 because you can have 6, 7, and this can't be 8, though, or 9. Because it has to be less than another digit. So, can you have 5, 5, 6, 7 is the question. That's what I'm looking at. So say this was copycatting. You'd have to have this be 5, 6, 7. That would be 9. 6 would eliminate 6 there, so that's 5. 5 would eliminate 5 there, it's 4. 5 would eliminate 5 there, it's 6, which would make that 8. 6 would eliminate 6 there, so it's 7. That's 5. So far, that's okay. 2 could not be the copycat digit, so 2 would have to be there. No 1, no 2, no 4, no... So this digit would not be possible. It would not have a 7 as a possibility. Because it can't be 2 because we already have 2 copycat here. It would have to be 7, so this is not going to work. So either way, if this is a copycat, this can't be 1 to copycat it, and therefore that's 1. If this is copycatting something, it's only copycatting a 1 here. So this is 1 no matter what. We don't know whether the 1 is either of them. Where is 1 in box 6? It has to be one of these 2. Now that's interesting. Oh, this is interesting. So these digits, this value must be smaller than that. But this value is larger than that one. And we have a guaranteed 1 here. Can we have a 2 here? If this is copycatting... Yeah, I mean, 2 could be either of these. Oh, this is guaranteed to have 5 or 6 here, so that eliminates 5 and 6 in the rest of the column. Okay, so that would have been easier. Because this can't be 5 or 6 here, because this must be 8 or 9 as a digit for this value to be 8 or 9. So this is 2 with the other 8 or 9 here. So 5 is one of these 3 digits, interestingly enough. Obviously, we have 2 as one of those 2. Oh, that's interesting. If this is copycatting that, it's going to be 2, 8, or 9 in value. Well, it cannot be 8 or 9. Because these two digits have to be greater than it, or equal to or greater than it in value, and 5, 6, or 7 is not going to be equal or greater to that digit. Oh, this could be 9. Oh, wait, ooh. That could be 9 there. Shoot. Okay, that's not... Well... Do we still have the 2 there? Okay, so these can't be 5 or 6. But this could actually be 9 here. Because you could have 9 and then 9. I made them. That's a pretty bad mistake. I don't think this can be 2, though. If this is 2, one of these values is... That means 2 in column... In the box 6. You're going to have 1 and 2 and the copycat here. So the 2 has to be on the thermometer. It can only be there, but then you would have 1 there, and that's not going to work. So that's still the same. But this could actually be 9, 9. And I totally forgot about that. Ugh. So we don't have a guarantee if this is... Well, you can't have 2 here. Wait, why can't you have 2 here? You could have 2 there, right? Oh, no, 2 is there. That's why you can't have 2 there. Okay. Okay. No, that still makes sense, then, I think. So because we know this is 5, 6, have to be here. That eliminates 5 and 6 from the rest of the column. So if this is copycatting that, it has to be 8 or 9, if that's the case. If it's not 1. So we're assuming this is 1. If this is 1, this can't copycat it because that would be 1 there. And if this is copycatting, it's copycatting it 8 or 9, but that's 2 digits that have to be equal to or greater than 8 or 9. And this can't be 8 or 9 here. Wait, why can't that be 8? These should be... This... No, because this is copycatting, right? So again, if we have a 1 here, this can't copycat that, because then this would be a 1 in value, and neither of these are copycat, and you have to have 2 digits which are the same or less than 1. And there's only 1 value digit that can be the case. So that's not going to work. So that's why if this is 1, we can't have a copycat here. We have to have the copycat here, but then that would be copycatting an 8 or 9. These 3 would not be copycatted, because this would be the copycat, and that's not going to have 3 digits greater than 8 or equal to or greater than 8 or 9. So no matter what, this can't be 1, which means this has to be 1 there. We don't know if it's pointing at it or not. Which means we have to have a 1 be one of these 2. 2 is one of these 2. Um... Now that's interesting. The remaining digits in row 4 are 3 through 9. No 9 there because of 9 in the column. Remaining digits here are 3 through 9. Remaining digits here, 1 through 8. No 1 there, though. Okay. So this could actually be copycatting that as an 8 or a 9, and then you have 9 and 9 there. Well, obviously, if you have 9 and 9 there, that would be 8. So that seems fine. Copycat, 9 cannot be either of these. Because you would have to have... 9 cannot be a copycat cell anymore. Hmm. Let's do digits, because right now this is kind of confusing me. No 9 as a doublet, as a copycat. No 7 as a copycat. We can't have 8. But we could have the 7 as a value here. We cannot have a 7 as a value here. Because then this would have to be greater than 7, because they are in the same box and neither are a copycat. So that's why this couldn't be 7. It cannot be 9 for the same reasoning, because 9 can't be in a copycat cell. So we have 2, 4, 5, 6, and this can't be 7 or 9. This can't be 9. So that's fine. But this could still have value of 1, which is why this could be 1 there. And this could be copycat. We could have 9 and 9 there. That actually does work. Whichever digit is here has to be the same as that. So let's make this A, I guess, and this is 2 and A. A can again be 9 there, or it could be there. Can this actually be... So if this is 7... So say this was 7. That means this is the sum of the first 7 values. That would be a... Actually, that would be a lot. That would be 7 twice. Seven twice. And then 3, 4, 6, 8, and 9. So everything but 1, 2, and 5 would be included. So that's 44, I think. So 45 minus 125 plus the 1 becomes a 7 in value. So that would be 44, which would force this to be 9, if that were the case. To add up to 45, but then this 7, you'd be losing the 7 and gaining a 1 in value, which does not work. So then that would be less than 44. So this can never be 7. Therefore, this is 6, which makes this 5, which makes that 7. This 6 in value is there, so that points at... No, we already knew that. That points at that. So far, all the greens are not well, actually, none of the... Yeah, all the greens are not a copycat cell. So this must be 6 in value. That means this can't be 6. This is 5. That makes that 4. Oh, that's interesting. No 4 or 5 there. No 5 there. Where is the 5 in box 7? It has to be here. So that's 5. That eliminates 5 there. No more 5 in the row. This, then, 6 has to be less than this digit, so this can't be 6. This is 8, 9 as a pair. That eliminates 8, 9 in the rest of the box, so this is a 6. 6 eliminates 6 there, so this is 9. This can't be 6, so that's 8. 9 eliminates 9 in the rest of the box and column. So then this cannot be duplicating an 8 or a 9. But that's still not that helpful. That eliminates 5 and 8 in the rest of box 9. So no more 5 here. No more 8 in the box. No more 8 in the column. This is the first 6 digits. This is the first 6 digits. Does that work? Yes. As long... Okay. So we're missing 3, 4, and 7. So this is what? So we have 1, 2, 5, 6, 8, and 9 here for the first 6 digits. 1, 2, 5, 6, 8, and 9. I don't know if that's going to work. 1, 9, 2, 8's 20, so it's 31. So we have 31 here. This must be equal or less than 31. We have 6 at minimum, 3, 4. Um, 6, 7, 9. What is that? Okay. 6 in value. If we have an 8 here, then that's the lowest that's going, these first 6 digits are going to be. So that's 3, 4, 6, 7. We have 2 6s. That's 12. Plus 3, 4. That's 7. 19. Plus 7 and 9. That's 35. That's too big. Oh, these can... No. Okay, so yeah. Okay. I forgot. You can go... These can be the same. So these could be the same digit. Okay, so that definitely has to be 5. That definitely has to be 4. That eliminates 5 there. This could actually still be 5. So we don't have a guarantee there. But, yeah, the problem is, if this cannot be 6. If this were 6, the problem is that this is not going to add up. This adds up to, if the first 6 digits add up to 31, this is going to be at least 6 with 3, 4, and another 6, 7, and 9. And that's way too large. So this is at least 35 here. Can it be 8? So this is not 6. That means this is an 8, 9 pair. That eliminates 8, 9 in the rest of the box. This digit must be equal or less than this digit. So we cannot have a 7 there. It's 5. This is 5, 6 as a pair. That eliminates 5, 6 in the rest of the row. So this cannot be 5, 6. This can't be 5, 6. It's 4. So no more 4 there. That eliminates 4 in the rest of the row. So this can't be 4, it's 3, which makes this not 3, that's 4. So 2 and 4 add up to 6. No more 4s here. So this is copying the 1. Right. This is copying here, this is copying here. Can we have 8? 8 would be 31 plus 4 plus 1. 36 does actually work. So this is A, this has to be B. That doesn't really help us much. 3 eliminates 3 in the rest of the row. So one of these, this can't be 5 because of 5 in the box. So one of these two is a 3. 5 eliminates 4 and 5 eliminate 4 and 5 in the rest of column 7. Interesting. So, what is the possible digit here that could be in a copycat cell? Can't be 2, can't be 7, can't be 9. It has to be a 6. So that eliminates 6 from the rest of the copycat cells. 3 eliminates 3 in the rest of this column. So 3 is one of these digits. 4 can't be here. 4 and 5 both have to be here. Six is one of these copycat cells, so 6 cannot be here, cannot be in the rest of the box. 7 can't be here because of 7 in the column. 7 can't be here because of 7 in the column. No 6 here because of 6 in the row, or 6 in the column. So 6 is guaranteed to be the copycat cell here. That means this can't be 6. We can't have 6 here because of the 5-6 pair in the row. 6 can't be here because of 6 in the column. 6 can't be here because it's a copycat cell here. So where is 6 in row 9? Or actually box 9. It has to be here. So 6 eliminates 6 there, so it's 9, which makes that 8, which makes A 9. So this is a 2-9 pair here. Okay. So no more 9 in box 8. So 8 has to be one of these two digits here. That eliminates 8 in the rest of the row, so this can't be 8. It's 3. No more 3 there. No more 8 here. We have a 5, 6, 7, 8 quadruplet, which eliminates 5, 6, 7, 8 in the rest of the row. So this can't be 5, 6, 7, or 8. It's 9. That eliminates 9 in the rest of the row, so this is 2, 7, 8 as a triplet. We have a 2, 6, 7 triplet here. In column 7, that eliminates 2, 6, 7 in the rest of the column, so no 7 there. It's 9. No 9 here, no 9 here, no 9 here. Well, none of these could be 9 because we have a 2-9 pair there. 9 can no longer be here because of 9 in the column. If this were copycatting this digit here, it would have to be either 2 or 9. If it's 2, these digits would not be copycatted and would have to be less than or equal to 2. But we would have to have 1 there and 2 be there, and therefore it would be decreasing. So that's not possible. If this is copycatting a 9, this digit would have to be at least 9, but it's not because of 9 in the column. So this cannot be the copycat, which means this must be the copycat. That's copycatting the 1. And then this can't be copycat anymore, so this must be copycat. It's copycatting that digit, which cannot be 1, because the 1 in value is not going to be less than another digit. So 1 cannot be here, 1 has to be there. That eliminates 1 there, so it's 4 and 1. This is going to be 4, 5, 6, or 8 in value. So this has to be great. This digit specifically, okay, this is not going to be pointed at, so this is the one that's pointed at. It has to be at least 4. Okay. And if they were the same digit, that actually does kind of work. This has to be copycat, so that's 6. That eliminates 6 here. This becomes a 2-7 pair. This can't be 7. If this is 7, that would force this to be 7. at least, but then we have 2 sevens in the row. So this is 2, which makes that 7, which makes this 8, which makes that 2. So no more 2 here. 6 is a copycat. This can't be 4 or 6, it's 5 or 8. Because these two digits have to be different digits. That means none of these can be 5 or 8 since they both see that cell. This can't be 5 or 8 because it sees that cell. So no 5 there. So either this is 5 or this is going to be 5. Interesting. This can't be 5 or 8 also because they both see the different 5 or 8s here, which are in the copycat cells. 2 eliminates 2 there, so this is 9, which makes that 2. No more 9 in the row. We have a 6-7 pair in row 5 now, which eliminates 6-7 in the rest of the row, and it's going to be 6-7 in the rest of the box. So no 6-7 there. These can't be 6 or 7. No 7, no 6 here because of 6 in the row. No 7 here. We have a 3, 4, 5, 8 quadruplet in box 5, which eliminates 3, 4, 5, and 8 in the rest of the box. No 5, 8 in there, so it's 9. Okay. Um... 3 eliminates 3 in the rest of column 9. So that's 4, 5, 8 as a triplet, which eliminates 4, 5, 8 in the rest of the box. That's 3, 7 as a pair here. Let's just double check. We have value 1, 1, 7, 8, 8, 8, 8, 8, 9, 9. 6, 7, 35. Does it? Actually, what is this value? So this is 8. So 1, 9, 2, 8 is 10. 4, 5, 6 is 15. This is 36. Okay. So then this must be 35. This had to have been at least 35. So that means this has to be 6, 4, and 9. That's 19. Plus 3, 7, and 6. 3, 6, and 7. So 19 plus 3, 6, 7. Well, you're guaranteed 3 and 7 here. So 6, 4, 9, 19 plus 3 and 7 is 29. If we add an 8, that's going to be 37, which is too large. So it must be 3, 6, and 7. So this can't be 8. This is 3. That makes this 7, and that's 6. That eliminates 6 there, so it's 8 and 6 there. That eliminates 6 there, so it's 4. So this cannot be 4. This becomes a 5, 8 pair here. Interesting. 4 eliminates 4, and 3 eliminates 3 there, so that's 4. No 4 there, so this is 5 or 8. 4 eliminates 4 in the rest of the column. 4 eliminates 4 there. This is a 5, 8 pair. That eliminates 5 and 8 there, so it's 3. Not 3, that's 4. 7 eliminates 7 there, so it's 3 and 7. 3 eliminates 3 here. That's 5, 8 as a pair. That eliminates 5 and 8 there, so it's 3. Okay. So we know these two digits are the same, so that works. Okay. If this is 8 here, which would make that 8, what are the first 8s in value? This is focusing on a 1. So we're doubling 1. So if we make this 8, this is 5, that's 8, right? And this is 5. The sum of the first 8 digits, or 8 values, would be 8, 7, 2, 9, 5, 1, 1, and 3. So it's 45 minus 4, and then minus another 6 plus a 1. So it's 45 minus 4, which is 41, minus 6, which is 35, plus 1 is 36. This would be the first 8 values here. That would be all of these values plus an 8. So that's 45 minus 5, which is 40. So that would not work. So therefore, this cannot be 8 here. This must be 5, which makes this 8, which makes that 5. 8 eliminates 8 there, so that's 5. And that eliminates 5 there, so it's 8. 5 eliminates 5 there, so it's 6. This then also must be a 6, which makes that 5, because it has to be equal to or greater than that digit. No 5 or 6 here. It's 7, 8 as a pair. 6 and 7. 7, 8 as a pair eliminates 7, 8 here. So let's just double check this. 5 eliminates 5 there, so this is 8. 8 eliminates 8 there, so it's 7, which makes that 8. This can't be 7 or 6. 6 eliminates 6 there, so 7, which makes that 6. 7 eliminates 7 there, so it's 5, which makes that 7. This would have to be 5. So let's double check this. First 5 digits, or first 5 values, are 4. So this is 5 and 5, that's fine. This is 35, 36. 5, 3, 9, 7, and 4. So 4, 7, 9 is 20. 3 and 5 is 8. 28. First 5 values here. 7, 8, and 9. So this is 28 here. And this is 2, 8 is 10. And 5, 7, 9 is 21. So this is 31 here. So that should work there. So we have 5 values: 5, 5, 28, 31, 1, 1, 7, 8, 8, 8, 8, 8, 9, 9, 6, 7, 35, 3, 7, 6, 9, 4, 6, which is 35, and then 1, 9, 2, 8, 4, 5, 6, and 1 is 36. 6 to 6 is equal. 6 to 7 is greater. 1 in value to a 5 in value. 4, 5, 6 works. Copycatting the 1, 1, 2, 6, and 9. 5 and then 6. Yeah, that seems to work. So this is a 5. Yep, definitely hard difficulty. Wasn't too bad though, but overall just, yeah. The execution was pretty difficult. Logic also wasn't the easiest too. So, but it never felt like it was out of touch. It never felt that like I have no clue how to solve this. Always felt like I knew where I was going with this, which was nice. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.